Welcome all of you. In this video, you will going to learn about three-phase full wave rectifier. Three-phase full wave rectifier. So before you are going to see about the three-phase full wave rectifier, so just you will going to recall the single-phase full wave rectifier. When you go for that single phase full wave rectifier, it is classified into the two types. The types number one is a bridge rectifier, and type number two is a center tapped rectifier. So you just recall the diode bridge rectifier. What is a diode bridge rectifier? It consists of the four diodes. You can look the screen. In that one is previously single phase full wave rectifiers. You were seen there are two leg number one, leg number two. So only two leg, and here is that the top is you are connected to the load, and the bottom you have connected to that. This is a point you have connected. So that is a single phase full wave bridge rectifier. See, look it here, single phase full wave bridge rectifier. So leg number one, leg number two. So here is the you have connected to the resistance. Okay, here is how many switches are used? Four switches are used. Here is there are two lines. One, it is connected between anode and cathode. Here is another line is connected between anode and cathode. Okay, if you have added, here is a phase neutral, only two lines. If it is three phase means R, Y, B. So three line will come, the same diagram you can take it, and you have connected one more leg. If you have connected one more leg means that is called a three phase full wave rectifier. So now you can look it, here is a one line R, Y, B, or you can do the A, B, C, whatever it may be. It is like you will going to make on that ones. So this is about that three phase full wave rectifier, three phase full wave rectifier. So first one, so what is a input source? Input source is a AC. AC is a three phase power supply RYB. What is the what about that one, this input source? Somewhat you will going to see what is the meaning of RYB, or you can give the name ABC. There are three sinusoidal waveform. There are three phase. Three phase. R phase, Y phase, and B phase, or you can give the name A, B, C. What is the difference between the one phase to another phase? 120-degree angle. R phase to Y phase 120, Y phase to B phase, Y to R Y B, Y to B is 120, another one is B to R is a 120-degree. So like what will happen? So like it is a Y type of method, like it is developed about that Y, so R Y B, like it is developed. So one phase to another phase is a 120-degree. Actually, that is they will going to say about that RMF rotating magnetic field. Based on that one, this induction motor is operated like it is further studies are there. So you can look at this is about that three phase input of the sources. So here is started from the phase number A. Phase number is A phase is started 0 to 180-degree. So after 120-degree, after 120-degree, second phase is started. It is going to conducted. After from the second phase started after 120-degree. After 120-degree, the third phase is going to started. So like it is the process is repeated. So after 120-degree, if it is after 120-degree, what it is going to start? So it's a A phase again it is going to start. So see that one, this is a brown color, brown or red color. So this red color again it is a 120-degree. Once 120-degree is over, then this it will going to start to conduct. Again it is to start to conduct. So like RYB, or in terms of ABC means ABC, A, B, C after that A. So like it is going to process is repeated. So next you will going to draw the waveforms. So this is a waveform. What about the waveform? See here, like this is a waveform, continuous of the waveform. So you will going to get it on the continuous of waveform. So how to draw the continuous of waveform? So once you have draw that one here, this waveforms, Okay, so once it is the input waveform is after drawn the input waveform, next you will going to draw the output waveform. What about the output waveform? How to draw? It's very simple to you can draw the output waveform when alpha is equal to 0. When alpha is equal to 0, actually it's a diode rectifier means your alpha value is nothing. You don't have the firing angle, so alpha value is 0 only. So how to draw? See here. So you will going to bearing. So from here to. So like you will going to draw on the top. So what is the meaning? So here is a phase is conducted. Once B phase start to conducted, B phase. So once Z phase start to conducted, C phase. Once A phase is again start to conducted, A phase. So like your waveform. So this is a waveform for that your full wave. Are you getting the full wave? Okay, full wave rectifiers. So the waveform is similarly it is look like what is type of the waveform? Single phase full wave waveform. So this is a method. So if you doesn't understand, I will going to erase it. I will going to draw again for your understanding purpose. Okay, so this is what is a waveform. This is a waveform for that is 3-phase input AC waveform. 3-phase input AC waveform. How to draw this waveform? First A phase. Okay, first A phase you will going to draw. Okay, one cycle you can draw. So once it is drawn from 0 to 120 degree you can draw. After 120 degree, second phase you will going to start to conduct it. Okay, if you will going to draw with the help of the graph sheet, you will going to get very clear about that one. Once you will going to note on the x-axis, then you will going to draw. After 120 degrees, B phase you can start to conduct. Once B phase started means, so from the point 120 degree you can note down, then next to C phase you can start to conduct. Once C phase is start to conducted from the point 120 degree, after that what is that one? A phase it will going to conducted. Okay, so like it will going to draw about the input waveform. One more time you can draw for the input waveform, that is called you will going to say output waveform. So you will going to second time when you will going to draw that second time when you will going to draw output waveform purpose, you can draw for that in pencil you will going to draw. So use that with some stick pen or your pen it is used to. Now you can draw the output waveform. How to draw the output waveform? So like I will going to drawing the output waveform. So you can draw. So A over B. Then once C started, then it is go to the C. Once it is C is over, then A is started, then A is you can go, then B, C. So like it is the single phase. Okay, how you are going to get in single phase full wave rectifier waveform? The same method you will going to get that one. So it's a full wave rectifier waveform you will going to get. So coming back to here, okay, this is a input waveform. Now we will going to go back about that one. So here is a drawn about that waveform. So just you will going to look it on that one. So this is a waveform about that one. So here how do they will going to draw on that one? So here like it is they are going to draw on the waveform. Okay, so I have drawn about this waveform. So you have to keep on look from this to here. So they have further divided because from here to here is 120 degree. So 60 degree, 60 degree, 60 degree they have divided. Okay, do you know why 60 degree, 60 degree? So I hope you are going to get it done. Okay, so this is a input waveform. Another one is what I have. So this is the first is they will going to draw. You can draw for that input waveform. So 120 degree, after that B, another 120 degree after once it is started. So 120 degree after that is C. Like you can after C drawn. So 120 degree once C started from 120 degree gap, next A phase. So like you will going to draw. Once you will going to draw for that input waveform, then next one more time this is a waveform. Okay, input waveform you can draw for output purpose. How to draw the output waveform? So like you will going to connected. Okay, this is a point you will going to start to you will going to draw. So this is about alpha is equal to 0. So when you further deep you will go for that one. Okay, from here to here, what is that angle? 120 degree angle is there. So here dotted line. So from here to here is a 120 degree. So that 120 degree I will going to split into the two. So 60 60 60 60 60 60 60. So I will going to I will going to split it. Why do I want to split it? Why do I want to split it? Very simple. Now we are go for that operation or working function of that the diode. What is that one? 3-phase. Okay, full wave rectifier. Okay, working functions. How many things? So 60 degree, 60 degree, 60 degree, 60 degree. Okay, why 60 degree? How many steps? There are 6 steps. How many steps of the operation you are thinking? It is a consist of the 6 steps. So what are the 6 steps? It is 6 steps. How many number of the diode is there in the circuits? There are 6 diodes are there. Okay, how many diodes are there? Just you can recap. How many number of the diodes are there? 6 diodes are there in that. Okay, in the circuit diagram it consists of 6 diodes. Okay, how do they mention? 1, 3, then after that 5 odd number in the top, then next one is a even number. So even number, first they will going to leave that 2, then they will going to start about the 4, then after that 6, then after that 2. So like about that the diode is a number, is they are going to give the numbers. Okay, so each one it will going to conducted angles. Okay, each one totally it is conducted, it is a 120 degree it will going to conducted. But okay, what is the angle difference between one switch after that second switch is a 60 degree. So that's why it's a 60 degree. Okay, if it is that one, how it is conducting sequence? So 6 1, and next one is 1 2, then next one is a 2 3, then next one is a 3 4, the next one is a 4 5, the next one is a 5 6, next one is a 5 6, the next one is 6 1. It's a process repeated. So 6 1, how many 1 2 3 4 5 6 steps. Okay, like it is conducted. Okay, in pace wise, pace sequence wise, how it is conducted? What is the pace sequence? So like it is the 3 pace. So R pace, Y R pace, then Y pace, then next one is a B pace. Okay, there are 3 pace. What is the angle I said? So R pace to Y pace 120 degree, and Y pace to B pace is 120 degree. From B pace to R pace is 120 degree. So like it is the angle of that one. What is the sequence wise? It is triggering RY RB. Okay, the same we will going to write about the 6 steps. RY R, okay, RY, then next RB. Next one is the Y. I will going to write about Y. So Y, after that what is that? YB, YR. It's a little bit difficult to I am going to write, but you can listen that concept. Okay, they understand the concept. Okay, okay. Then R is 2 times. Then Y is 2 times. Next one is B. Then B. I will going to write about the B again and the B. So what about that one? B to R, then after that B to Y. Don't write out about the B to Y, after that B to R. So in that clockwise B to R, after that B to Y. So B to R and B to Y. So this is about the 6 steps of the sequence. This is the switches conducting wise, it is a sequence. If you have look it on that ones, okay, odd top is odd number, bottom is a even number. If you have looked at the 6 steps, one from the top, one from the bottom, one from the odd number, one from the even numbers. Okay, actually let's you can see here is a, do they consider as an RYB? No, ABC they are considered. So you can just R means A means Y means what? B. AB, they are written AB, AC. Yes, see that one, AB, AC. So step number 1, this is step number 1, step number 2. Next one, what about that one? So BC. Next one is a C. Okay, okay, B, C. So this is the BC and the BA. Okay, this is step number 3, step number 4. So next one, step number 5. Next is step number 6. So instead of R by B, they are considered as an phase as an A B C. So A B B, then C C. Then here is A means A B A C. Then next one B B, after the B C, then B A B C. Another one is B A, then C C A C B. Like the 6 steps. That's all. This is a method. So once this is a method based, it is conducting. This is about the operation of the 3-phase full wave rectifier. And what you want to know, what about each diode conduction period? Each diode conduction period is a 120 degree. It will going to conduct each diode. It will going to conduct it on that one 120 degree. So what about here is conducting 1 and 4 is conducting. Okay, here is a okay. Each one is first one is a each one conduction period. So every one conduction period is a 120 degree. So that one you should be clear. This is a point number 1. Okay, what is the difference between the first conducted, after that second conducted? So that is called 60-degree gap. So 60-degree gap between the 1 to 2 is 60 degree, 2 to 3 is 60 degree, 3 to 4 is 60 degree. This is a point number 2. So first one, every diode is conducted 120 degree. Okay, first step, first diode to second diode is conduction period is 60 degree. Okay, what is the angle between 1 and 4 conduction period? 1 and 4 conduction angle period is 180 degree. So 1 and 4 conduction angle between that one is conducted, after that 4 is conducted means 180 degree, after that it is conducted. Okay, for example, you have see that one. So this is here, okay, here, okay. So 0 to 60 degree, this is a 0 to 60, then 60 to 120, then 120 to okay, 0 to 60, okay, 120, 180. So after 180, what is conducting? Fourth one is conducting. So everyone, this is the top, okay, 180 degree. After that, bottom is conducting. Then only what will happen? Okay, the short circuit will go to avoid it. So now we can back to the circuit diagram. So this is sequence. That's why here is represented on that one. So the sequence. What about I said about the sequence? So 6 1 1 2 2 3 3 4 4 5 6 1. Like the sequence, it will going to operate it. So this is the simplest method. You will going to draw the circuit diagram, and another one is the waveform, and the waveform after followed by the explanations. What about each diode conduction period? Each one conduction period is 120 degree. Okay, what is the sequence between 1 to 2? 160 degree. 60 degree after that is 2 to 3 60 degree. 3 to 4 distance is okay 60 degree. Okay, what is the distance? Okay, distance between, okay, conduction difference between the 1 and 4. 1 and okay, actually their number is differently they will going to give, so you should be conscious. So top and bottom, what is the differentiation? The top and bottom differentiation is 180 degree. So do you know why they are given the numbers 1 3 5 2 4 6? You may be change, so you may give 1 2 3 4 5 6, but when you will going to give 1 3 5, okay, here is a 2 4 6 means I said about that 60 degree gap, that is 60 degree gap, it will going to follow that order only. So that's why they are not given 1 2 3 or 1 2 3 4, whatever you can give, but it will going to follow that type of order only. Okay, so you will going to look about that once. Okay, so this is a method you will going to draw the waveforms. So the equations, just you will going to look the equations. Okay, if you have any queries, you can ask me in that. Just look the equation and then you can ask me the queries. Okay, so thank you for that one. So just you can recap about that one, summarize. 3-phase full wave rectifier, it is similar to that single phase full wave, okay, bridge rectifier. Here is one more leg they will going to connect it, and it consists of the 2 more diodes, A phase, B phase and C phase. Okay, like you will going to connect it. Okay, top you will going to give the number 1 3 5, bottom you can give the number 4 6 2. You will going to give the numbers. So why do you going to give means it is a sequence wise, it will going to operate at a purpose. What are the 6 steps? So 6 steps is a 6 1 1 2 2 3 3 4 4 5 6 6 6 1. Okay, what is the phase sequence wise? Okay, RY RB Y YB YR, then another one is a BR BY. So like it will going to operate on that 6 steps. So power reset will going to operate on that one. So 60 degree angle. Next 3 major point is the, okay, each diode is conducting period is 120 degree. First diode is conducted. Okay, at every time, every steps there are 2 diode is conducted, one from upper, one from lower, one from upper, one from lower. You can draw for that equivalent circuit of that ones. Okay, yes. So each diode 120 degree. Then second one, first diode to second diode conduction period is what is conduction period? 60 degree. Then next one. Okay, next one, top diode and the bottom diode conduction differentiation is 180 degree. That's all. Thank you.